Modern machines used for harvesting, cultivating, ploughing, watering, working, cutting, round bale wrapper, combine harvester, ploughing, fertilizing. Combine harvester. The modern combine harvester, or simply combine, is a versatile machine designed to efficiently harvest a variety of grain crops. The name derives from its combining 4 separate harvesting operations: reaping, threshing, gathering, and winnowing to a single process. Among the crops harvested with a combine are wheat, rice, oats, rye, barley, corn, maize, sorghum, soybeans, flax, linseed, sunflowers, and rapeseed. The separated straw, left lying on the field, comprises the stems and any remaining leaves of the crop with limited nutrients left in it. The straw is then either chopped, spread on the field and plowed back in, or baled for bedding and limited feed for livestock. Combine harvesters are one of the most economically important labor-saving inventions, significantly reducing the fraction of the population engaged in agriculture. Combine farm equipment. Combine, also called combine harvester, complex farm machine that both cuts and threshes grains and certain other crops. Combines are used in the harvesting and cleaning of cereals such as wheat, barley, corn, maize, oats, rice, rye, and sorghum, as well as a number of non-grain crops, including flax, rapeseed, soybeans, and sunflower seeds. An early primitive combine was a horse-drawn combination harvester thresher introduced in Michigan in 1836 and later used in California. See also thresher. Combines were not generally adopted until the 1930s, when tractor-drawn models became available. Self-propelled machines, capable of cutting swaths 2.5 to 5.5 meters, 8 to 18 feet, wide, appeared a decade later. Originally designed to harvest wheat, they came to be used to harvest many other crops. Mechanism. In design, the combine is essentially a binder-type cutting device that cuts and delivers the grain or seed crop to a threshing machine modified to work as it moves across the field. The cutting-gathering component, designed to take the grain with a minimum of straw, is sometimes called the header. A threshing cylinder rubs grain out of the heads against a concave surface. Some grain and chaff go with the straw to the straw deck, on which grain is shaken out and delivered to the cleaning shoe. Some of the grain and chaff goes directly to the cleaning shoe, on which sieves and a blast of air are used to separate and clean the grain. After passing through the air blast, the grain drops into a clean grain auger that conveys it to an elevator and into a storage tank. Straw drops out of the back of the combine in a windrow for baling or is scattered over the ground by a fan-like spreader. Some combines for use on steeply rolling land have a body supported in a frame by hydraulic cylinders that automatically adjust to keep the body level. Header. Header, machine for harvesting grain, developed in the United States, Canada, and Australia. Along with the binder, it was standard equipment for harvesting wheat in the United States and Canada until early in the 20th century, when the grain combine was widely adopted. The header clipped the heads of grain from the stalks and elevated them into a header barge, a wagon with one low side over which the cut material could be pitched out with forks onto a stack. Later in the autumn, the grain was threshed by a threshing machine. Combine header. Combines are equipped with removable header that are designed for particular crops. The standard header, sometimes called a grain platform, is equipped with a reciprocating knife cutter bar, and features a revolving reel with metal teeth to cause the cut crop to fall into the auger once it is cut. A variation of the platform, a flex platform, is similar but has a cutter bar that can flex over contours and ridges to cut soybeans that have pods close to the ground. A flex head can cut soybeans as well as cereal crops, while a rigid platform is generally used only in cereal grains. Some wheat headers, called draper headers, use a fabric or rubber apron instead of a cross auger. Draper headers allow faster feeding than cross augers, leading to higher throughputs due to lower power requirements. On many farms, platform headers are used to cut wheat, instead of separate wheat headers, so as to reduce overall costs. Dummy heads or pickup headers feature spring-tined pickups, usually attached to a heavy rubber belt. They are used for crops that have already been cut and placed in windrows or swaths. This is particularly useful in northern climates such as Western Canada, where swathing kills weeds resulting in a faster dry down. While a grain platform can be used for corn, a specialized corn head is ordinarily used instead. The corn head is equipped with snap rolls that strip the stalk and leaf away from the ear, so that only the ear and husk enter the throat. This improves efficiency dramatically, since so much less material must go through the cylinder. The corn head can be recognized by the presence of points between each row. Occasionally row crop heads are seen that function like a grain platform, but have points between rows like a corn head. These are used to reduce the amount of weed seed picked up when harvesting small grains. Self-propelled gleaner combines could be fitted with special tracks instead of tires to assist in harvesting rice. These tracks can be made to fit other combines by adding adapter plates. Some combines, particularly the pole type, have tires with a deep diamond tread which prevents sinking in mud. The threshing process. Despite great advances in mechanics and computer control, the basic operation of the combine harvester has remained unchanged almost since it was invented. Power requirements over the years have increased due to larger capacities, and some processes such as rotary threshing and straw chopping take considerable power. This is sometimes supplied by a large tractor in a pull-type combine, or a large gasoline or diesel engine in a self-propelled type. A frequent problem is the presence of airborne chaff and straw, which can accumulate, causing a fire hazard, into radiators which can become plugged. Most machines have a long, longitudinally mounted rotating cylinder with plates similar to rub bars, except for in the above-mentioned gleaner rotaries. There are usually two sieves, one above the other. The sieves are basically metal frames that have many rows of fingers set reasonably close together. The angle of the fingers is adjustable, to change the clearance and thereby control the size of material passing through. The top is set with more clearance than the bottom to allow a gradual cleaning action. Setting the concave clearance, fan speed, and sieve size is critical to ensure that the crop is threshed properly, the grain is clean of debris, and all of the grain entering the machine reaches the grain tank or hopper. Observe, for example, that when traveling uphill the fan speed must be reduced to account for the shallower gradient of the sieves. Heavy material, e.g., unthreshed heads, fall off the front of the sieves and are returned to the concave for re-threshing. The straw walkers are located above the sieves, and also have holes in them. Any grain remaining attached to the straw is shaken off and falls onto the top sieve. When the straw reaches the end of the walkers it falls out the rear of the combine. It can then be baled for cattle bedding or spread by two rotating straw spreaders with rubber arms. Most modern combines are equipped with a straw spreader. Rather than immediately falling out the rear of the combine at the end of the walkers, there are models of combine harvesters from Eastern Europe and Russia, e.g. Agromash Yenisei 1201, etc., that have straw catchers at the end of the walkers, which temporarily hold the straw and then, once full, deposit it in a stack for easy gathering.